Hey everybody, this is Larry. This is Leetcode Weekly Contest 442. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This is a live recording of me just solving this as a virtual contest. Definitely, if you would like explanations, they'll be on each problem will have its own video, so definitely search for that. But yeah, let's get to it. Am I ready? Scrolling down slowly so no spoilers. Okay, click on this. Am I ready? Let's go. Yeah, I hope everyone's doing okay. I feel like last contest or last virtual contest I did okay. So I just kind of, I don't know, maybe need to be better, but that's unrelated to like I feel like well, actually I got 2 wrong answers on Q1 last week, right? So that was not great. So maybe a little bit more careful on the easier problems. So yeah, all right, let's go. 3, 2, 1, go 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 go. Do 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 do. Ooh. Yeah, the clicking was. Oh no, we're doing the same thing again. Where the click, where I feel like we're doing the contest way too soon after the thing. But I think that time it corrected itself. So hopefully this corrects itself eventually. Okay, let's go. One container W. As for say what? N by index. 1 with weight. Okay. Total weight of all containers was not right? Deck has 4 cells. Should contain what the? What am I supposed to read? Man, this is a reading problem. You're given n, which is n squared for some reason. Each cell in the deck contains 1 container with weight with exactly W. Okay, so you have 12 things. Oh, okay. I don't know why there's so much reading thing that they want you to do, but you just do a linear. I mean, you could probably do a binary search, but for today, I'm a little bit, or for the easy problem, I'm not gonna worry about it. So we have n squared, right? So you have, yeah, so you have 9, 5 of them, 4, what? This is so confusing. So max weight divided by W is gonna be the max container. So then we just return min of either n square or this, right? Have to give it moved. Am I misunderstanding this one? I don't know. Somehow. Oh, auto something parenthesis closing. Is there any edge case? Maybe not. I don't know. Okay. It's got. I've been careful for obvious reason. It's fine. Extra 20 seconds or even half a minute is fine, right? Anyway, all right, focus. All right, 2D properties n times m and an integer k define and intersect a b where a number of distinct integers common to both array a and b. Huh? Intersect a b, that we what? Oh, a and b. Okay. I don't know why I don't use I and j for it, but okay, fine. Construct undirected. Okay, construct an undirected graph. There is an edge. If so, we have given k. If the intersection is greater than or equal to k, there's an and okay. I mean, that seems pretty straightforward depending on the constraints, and the constraints are silly, so it's just yeah. So for j for k, okay, fine, right? So n is equal to thing for properties, right? Then now we're just going to do something like for I in range of n, for j in range of I plus 1n, right? Or maybe even just right? P dot append properties of I. So we want it to be a set, right? They're unique, distinct. Convert to a set, and then now we have p sub I and p sub j, and then length of this is greater than or equal to k. Then there's an edge, right? Yeah, then we could, I guess we should use union fine, actually. This is also one of those things where if I had free win code, that would be nice, but it is what it is. I probably have it somewhere, but I always like, I don't know. I don't mind typing it out, I think. Okay, fine, right? So then now, let's only do this intersection if there's a typo. Union ij, and then now just the number of components, is it? Return count. I guess there are a couple of ways to do it. Just set of parents, right? Nope, that's not the, nope. That's how you make a silly mistake. Okay. Was it 312? Alright. Don't think I did anything too silly. Okay. Probably could have been faster if I had pre-run code like some people do, but it's fine. Q3. Find the minimum amount of time to brew potions. Skill and mana, and some each potion has a mana or the wizard, and must pass through order to brew properly. The time must pass. Each wizard begins working on potion exactly when it arrives. What does that mean? Okay. Return the minimum time. Instead, get to immediately. Okay. I see. So you have to kind of start. So the start time is the tricky part, because there can be overlap, but you have to be careful, right? I guess that's the thing that they want you to care about. And the mana has to be done in order. Okay, the potions have to be done in order. So you have 5. The first one is going to take. Well, the skill is going to be the skill is just skill times mana. So that, what does that mean? It's just binary search every potion and then greedy, right? I guess so. Okay, fine. Is that fast enough? 5,000 skill. The time. What is the time? Well, I guess it doesn't matter. It's only 20 for each one. That's like 5,000 square. 5,000 square times log. No, that's too slow, isn't it? I did too naively. Do I have to store something? Okay, so why is this? Okay, what is the criteria that I'm thinking about? Maybe exactly. Okay, so this. Okay, I think the thing is that this explanation is a little bit wonky in the sense that it tells you when it ends, but not start. Well, I guess the start is the previous one, so I think that, so that means that actual thing that I care about is the start time, right? And then 0, and then we just take the. I guess it's still the all-time C is 5,000 squares. Still a little bit sketch, but I hope that makes sense. But it's just greedy then, right? You take you loop and then you just do it. So I don't need to binary search, because then now wizard 3, the earliest time is 60, earliest time is 40, and so forth, right? It's just maths, but it's tricky, right? So here, working backwards, you would say 61. And then it's just a delta, right? So that means that the one before that. $45. This is 5, doesn't change. Wizard 1 is going to be a little bit awkward. I'm kind of bad at this. It's 5, and 45 is the 45 is the earliest that it can start. Earliest this thing start is 60. So what does that mean? So what that means is that given a skill, are we always limited by that? No, I guess not, because this is some awkward thing going on. What is the limiting function? Huh. I mean, it's still gonna be just like 2 linear scans. For binary search would be so much easier, but I think this is too slow even for this one. So the delta here is 4. I mean, it's some sort of propagation thing, but it's very awkward. How do I? Okay, so the first one is at 0. Right? Here was the earliest that it can start. So I have to figure out the delta, which is the start time of the first one, because everything else follows. Okay, maybe I guess that's really it, but it's still very awkward to do. Okay, fine. Well, at least I'm not good at it. I don't know. Math is always tough. Okay, so we. Nope. Right, and then now, so we went for the first one. So the first person available is equal to the last person available plus skill times manner, so skill sub I, nope, skill sub no, this is S, that's why I'm weird. Okay, I times manner sub 0, we're just setting up the first one. Something like that, right? So okay, so now we set up this thing, and then now the next person, when can we start? We have to find out the delta, right? So you don't even need T really, but so the start is going to be 0, so delta, right? I think that it's all math and I'm just really bad at it, but the biggest difference, I mean, but manner is fixed, so this is going to be 4. What is the relationship I'm missing? This is 4. Okay, so that means that earliest is 60, so 64. Here we have to fill backwards, maybe. Filling it backwards, this is either 4 from the previous one or 4 from the top one. Okay. And then we can, from the start time, we probably can deduce it. If the start time is negative, then we can get it. Okay, I guess that's fine. Okay. Yeah. I don't know. We use so much memory that is kind of scary actually. But yeah, I guess we'll see. So then I is equal to, so min of this, no, max, yeah. Max of this plus, so the previous thing, the previous time is available plus skill sub I times manu sub j, or, well, I guess this is just max of these two because the thing doesn't change, right? So of, well, okay, so it's max of that, but that's not right per se. Okay, so because we're doing it backwards, then okay. S minus 1 is equal to, oh, okay, plus this, where the I is S minus 1, okay. Now we're able to do this, where we have this, and also I plus 1, plus skill sub I times minus sub j, okay. And then now delta is going to be equal to the first time available. Is this right? No, this isn't right, is it? No. This is not right, because here this makes sense because we can just start whenever. But this has to be contiguous. So you can't just take the max of that. So that means that what happens? Okay, it's just an if statement with delta, I think. Okay, so you have, this one is fine, and then working backwards, it's not max, it's an if statement. So if plus skill sub, so this is not available. Okay, so earliest is equal to this thing. That's the earliest that we can do it. So if this plus this thing, if this is earlier than that, then delta is going to be equal, we add that to the difference, right? Okay. Okay, and then that's it. In theory, we actually don't even need this. We just update this. Maybe this is premature optimization though. Okay, fine. But then now we need to update all the deltas. So yeah, we need to update all the deltas or all the things. Oops. And then we just set and then we just return the last one used, I think. Apparently maybe not. Even this one as well, which is actually a little bit sad, but that's okay. We have the technology to debug. Okay, so this is what we expect. Delta is way wrong. Okay. Delta is 35. Why? So this is 64. Did I mess something up? Oh, I don't update. Sub I is equal to oh, we just up equal to, and this is a subtract, right? Oh, this is the earliest that it can end, and this is previous earliest, so that's actually wrong. Okay. Oh, then just p earliest, because we already calculated out the delta. Okay, still wrong in all the cases, but maybe we're getting closer. I don't know. 67, is that right? 64 is right. Oh, the delta is 0 is definitely wrong. 62 is definitely wrong. Why is that? This is segment 1, this is a 4. Oh, this is my off by 1 on this one, which is fine. This is a +1 here. Still wrong. Still wrong here as well. 53. Why is 53? Oh no, that's why on the first column. Though delta being 0 is a little bit awkward, but maybe not. This one, 47, is weird. Why is that? Why does it think it is 47? Okay. Math problems. Okay. I mean, this is... No, that's too high. Why does it think it's 47? So it's 64 is thinks the next one is going to be... Okay, so the next one is 4, so it thinks it's 16. So the earliest that it can do is 80. Right? Okay, if it goes 80, but it can, because next one has to be at least 86. 2 to 4 times 2? No, that doesn't make sense. Okay, maybe we'll print out the one without. What if we don't do anything? What does that look like? Debugging is the worst. Okay, so it looks like this. 16 sounds right, but 16 over, so it has to be +16, so delta changes. Okay, that's fair. Oh, we have to calculate the delta with respect to the new delta, so we're double counting. So it's going to be, how do I adjust? It's going to be this plus delta, but we'll have to adjust for the future as well. Okay, this is going to be too slow, but I just want to test it first. So would that fix it? No, that still doesn't fix it. Well, this is just really awkward. No, then you don't need the delta anymore, so delta could be 0, I think. Because it's not cumulative. Maybe? That's not right then. Right? I'm really bad at this. it's one of those problems that maybe I should be debating skipping, and a lot of people got Q4. So, but why am I so bad at this? Is it math? Am I doing something like binary search would be easy, but it's just too slow, right? Am I thinking it wrong? Am I wrong in the no, the 5,000 manner. So that's okay. So we get the suffix, then why doesn't this work again? Once we get the suffix, so we get 16, we go, okay, 16, well, this has to be 16 before that, right? So why? So now it's, is it not 16? Am I doing math wrong? 4, 16, right? So okay, so it thinks it's 16. This one's fine. So minus 16. This is 66. 66 is too small because we need 4 times 2. So this is 68. So the delta is 2. Why is the delta not 2? Am I doing math wrong? 16, 64, 60, oh, plus 4. Whoops, no, not 2, 4. Okay, so then it goes to 72 to 80. Okay, that's fine for now. Right, and then now 72, what's the previous? Previous is going to be, it thinks it's 14 for some reason. Did I do my loop wrong? No. Okay, let's see. So 72 has to be 64, but as 20, right? So the delta, okay, so 64, the delta, it has to be 20, so 78 minus 64 is 14, which is where we get this, right? So that means that we have to add everything by 14. Why do I not add everything by 4? Oh, no. Oh, I'm just dumb. Huh. Even in my fake thing, I was dumb. Okay. Yep, now I get the right answer. Okay. Wow, what a bad typo. And that was supposed to be my test if it works typo. So that's pretty bad. Can't submit this. We need another array. Yeah, we need a delta array to accumulate it afterwards. Okay, fine. Probably could do this a little bit cleaner, but I don't know. I don't even know if this is fast enough, which is kind of the sad part. Is this right? I guess you don't need it, but then you need to accumulate it for the n. And I guess the intermediate stuff don't matter because everything is consistent. So all you really need is, okay, fine. So we actually don't need this array. What we need, just need a delta, right? This is maybe a current delta. We don't need this. We don't need this. All we need to do is actually just fix the last element. That's not true. That's not true. That's not true. This is actually a very annoying problem. But okay, fine. So then we add this here because we need it immediately. But then here, okay. So then actually what we want then is I plus 1 so that we add the next element. But we also add it here. So then now here we can do this. Except for that I plus 1 may be a little bit out of bounds, so we need to do something funky like this. And here now maybe we are good, or maybe not. Oh. And Larry is sad again. Is it cumulative? There. I had it, and then now I don't know how to fix the thingy. Oh, that's why actually, because this is supposed to be cumulative, but I didn't do it cumulatively. Okay, maybe that's still salvageable. What I just need then is d0 0. Okay. Is this even fast enough? I don't know. I took long enough, but let's go to, what is it? 5,000. We'll just try a big number really quick. Okay, is that fast enough? But I don't know how else to do it, honestly. 5,000 square is too slow. Am I 5,000 square? Kind of. This is a really crappy Leetcode problem again, kind of thing. I don't know, because I mean, can I do better? Is that what it's asking? I feel like I want to YOLO submit this, but maybe this is too slow. Maybe 5,000 square is too. If 5,000 square is too slow, why don't you just make it 10,000? I don't get it. Leetcode strikes again with, I don't know, like why 5,000? 5,000 is just like a bait for anything. Okay, can I go be a little bit? Oh, that got. But that's what I mean. It shouldn't need to be 5,000. It gets accepted. It's just silly. Like who are you trying? Like, I don't know. Just mind games. Unnecessary mind games is why I stopped doing these things live. And just try to see the. Let's see how my ranking is so far. Probably could have done that one a little bit faster. I had a couple of typos. That was pretty bad. 14 seconds. Come on, Leetcode. You could do better than that. Okay. Wow. People got in 2 minutes. I guess, you know, with the power of ChatGPT, anything can happen. All right, anyway, let's see if I can solve Q4 without the power of ChatGPT. Okay, let's see. Queries of I, you have left, right, queries of I let me get some drink. Find a way of integer nums. Okay, what does that mean? One operation, you can swap or select two numbers A and B. What does that mean? You make them smaller. Huh? What is a query? What does that mean? Query. Okay. Oh, I'm just misreading this. Oh, I'm reading this dumb. Okay. It's not a query though. It's such a weird thing to call it that, but maybe not. Maybe it's fine. Okay, so you have 1 to 2, and then here's 2 to 4. Okay. And then you have in one operation you can select two numbers and then replace them. And we have a lot of them, so you have to be able to do them relatively quickly. And the numbers are nuts, so you don't have to worry about it. What is the strategy here? I mean, there really is not that much strategy, right? It's just you have the number of users. And then there's the same problem that we always have done with the counting, right? Oh, but it's contiguous. Maybe the contiguous part is maybe interesting. Huh. It's just like a way. It's not a very algorithmic. It's a very problem-solving problem, but it's not very algorithmic because it's just doing the math. Maybe. I mean, there's maybe some edge cases, but it's not an interesting problem per se, if you ask me. But okay, 1,000 people got this. I mean, yeah, people are better at math than I am, so I'm not that surprised. But okay, so what does divided by 4 mean? Is it just log base 4? I don't get it. And I'm trying to think what the idea is. Okay, so here this 111. So it is just log base 4 round up or something, right? You have 4, it takes 1 move. You have 5, it takes 2 moves. And then yes, so 16 it takes 2 moves. And oh no, 16 is 3 moves, right? So okay, but so every power of 4. I mean, but you can't really but you can find the distribution, right? So the distribution is just log based 4. What does log based 4 mean? Log based 4 means that 10 to the 9 is 15, right? 4 to the 15. So 4 to the 15. That means we can maybe brute force on 15. You can do some because none of that matters. It's just it's a bitmask DP, isn't it? Huh. It's a very crazily disguised bitmask DP, it sounds like. And then you just kind of, it's just a parody of the numbers of things. Okay, fine. Because there's no choice other than matching up the odd parody stuff, right? Can it be odd? Well, I guess it can be odd in the sense that you just choose one that's already 0. I guess it probably even mentions it in this one. Actually, no, it doesn't. But that's odd that they don't have. That's odd that they don't have one. But okay, so just bitmask DP. Is that it on 15? Okay. Yeah, and that bitmask is actually very awkward because you can actually globalize it, I think. Right. And here, if bitmask is 0 to 0, so that means you're done. So you 0 move. Otherwise, okay. So what are the states mean, right? So you have a 15. You have one odd even parity. So you remove 115. Is it 15 squared times 2? I guess that should be fast enough. Still awkward, but fast enough, right? Can I mean, you probably could optimize this a little bit, but I think I'm just writing it the dumb way first. You also want to, okay, I mean, maybe that's fine. Now you can always take one from 0, so that doesn't matter. And the number of counts on 0 doesn't matter, so we have to be careful about that. So here, something like, we have to get rid of the zeros, so how do I write that in one? I guess maybe not. Something like that, maybe. Right, I think that's fine. It's a very ridiculous function actually, but okay, fine. Right, so then now it is just you move one over if that's the case. Does it have to exist? I guess so. We should. I think we should. I could be wrong, maybe actually, but. Because you can always just take one. Okay, fine. Okay, so now we're trying to minimize, right? So it doesn't have to be actually be infinity, but I think infinity is fine too. It doesn't even have to be that big. Keep it an int for slight performance benefit. So best org. Now we want to shift. We want to shift. We want to flip. Okay, so we flip those two, and then we also flip I mean, it's technically true, but I think I have to be careful about this. The states are fine. But it is more than one. If it's more than one, can you always pair them together? Do you want to ever pair them together? Maybe that doesn't make sense. I don't know. Okay, let's try the thing where we just do one first. Okay. What would that look like? Okay, so we flip one and one does 0 once, so it doesn't do anything. But then now we have to keep track of. Because then it's, yeah, you don't want to delete those. If they match up, then they can be eliminated. But is that always ideal? I guess that's always ideal, but it's still very awkward to write. Yeah, that's fine. Awkward is fine. We just need to do it. What part? This is only a 6-pointer. That's actually kind of. Maybe I'm doing this in a crazy man's way though, but maybe that's fine. I don't know. Okay, yeah, fine. So if okay, so if there was a one previous, then we don't feel great about this one, but that's fine. So it's this plus it's one move and then I times 2 moves or something, right? Otherwise, we can just keep it. In the base case, we can always just get rid of it all the way. I think No, it's not I over 2. It is I moves. Oh, I minus 1. Yeah, okay, so wait. Oh yeah, I guess it doesn't matter where the, okay, fine. I guess in this case it doesn't matter the way that I'm doing it, because you just get, but do I want to do it that way? Does it even make sense? No, because if it exists, then you pair it all the way down. But the states are different, right? I think this is fine. This is actually, those are 2 different moves. Because here you just repeatedly get 1 and 0. But that's a shortcut on a state. Is that shortcut on going to bite me? I think it might actually. So, okay, so in this case, you actually also want, but it's still the same cost. So that's fine. Okay. And then now, yeah, we do need this, but it's very awkward. Okay, so we do. But now there are 2 of the I minus 1 and J minus 1s. Okay, whatever. Let's just do. Right. I mean, I think this part is fine. I think this part is not going to change, but then if it exists, then we have to okay, so cost is going to be equal to 1 if this is PM. And cost we add by I minus 1, just because then we'll pair them up. I don't know if this is right. It feels very awkward. And also, like, if I'm wrong, it's very not easily debuggable. I have to trace so much stuff. But okay, so those are the, I think those are the things on the choices, and that assumes that we match them up. Okay, and then now this is annoying. I feel like it's very easy off by 1 here. Yeah, okay. I mean, these are just normal things. So we get R minus 1. So we have a 15 element, right? Okay, wait. And then now we just answer that append. So okay, so how do I do this? And then now it's for I in range of 15, I guess. Yeah, should put in a constant really, but unless I'm really wrong. If I'm really wrong, I'm really sad anyway. There are a lot of built-in assumptions here. Okay, so a sub I divided by 2. So cost, we add this times I, and then a sub I mod 2 or n1. So this okay, fine. If this is greater than 0, then we shift I and then we just go PM, right? Something like that. And then now we have to write that function as well. Okay. Okay, so one move is going to be 4, right? So yeah, so how do I do this? I guess I shouldn't for loop. Okay, so current is 0 to 1, maybe, right? So we don't count 0, right? Okay. Maybe start at 1. Then okay. If x is does 1 have 0? 1 has 1 move, Larry. Okay, fine. So we should start at so the 4 it's off by 1, but I think that's fine. We just have to remove 0. Remember to remove 0. So okay, so a of 1, 1. Okay. So then if x is greater than or equal to 4, no, it has to be exact. Maybe, I don't know actually. Okay, so if x is 4, then if x is 4, then there are 4 numbers. I think, yeah, okay. Then x minus current. Actually, a sub I should you go to max of, not max, is it? No, min of the current, or x. No, because it's delta. It's not just 4. It's the delta between 4 and 12. Why am I so bad at this? It's fine. You could do a prefix subtraction later, Larry. Yeah. I can't believe this part is the part I'm struggling with. I mean, I could believe it actually. I'm pretty bad at stuff. Okay, so okay, so then now 16 my phone. Yeah, okay, then it's just yeah. Wait, no, this already does this, right? But this thing is wrong, so I have to do it like this, and then now for something like that. I mean, this is gonna be nuts. So. Oh, I have to return the sum, right? Not just okay. That's actually kind of silly or funny. Which also makes, I don't know if it makes sense, but okay. I'm just going to keep it this way for a little bit. Oops. So that in case I need to debug, but I need to remember to remove it. Now, this is actually right, but I don't know if I'm just lucky or not. So we can actually, they only have, I could actually, well, I could print it out. One and 2 and 4. I mean, I guess that's fine. I don't know. I mean, I feel like I should test this one a little bit more because this is just too magical. This is I'm so bad that it's just hard for me to believe that I can get it on the first try anymore. There's just so many places to get it wrong. But yeah, so this is and no, that's right. 4 and 16. So 3 and 12, is that right? I think that's right. No, I mean, no, that's definitely wrong in the sense that you're off by 1 because the sum of these should definitely not. Okay, so this thing is maybe a little bit of a hack. Okay, 4 and 12, that's actually right, but so 0, 1, 2, 3. So 16 has 16 numbers. Okay, 4 has 4 numbers, so we're discounting 1, right? So what am I doing here? Well, I'm counting 0. I'm using 0 index, so I need to increment by 1. Okay, maybe. And then now we take out the 0 index the way that we did it before. So I think now we're fine. I think technically this should start at 1 is why this is a little bit awkward. Technically 0 is not a 1-digit thing, even though it may look that way. And as a result, kind of write it this way. Okay, that's fine. And then now we take out the 0-digit 0. Okay. Yeah, okay, fine. Right. And then here, maybe I'm testing, is this good enough for me to do? I don't know, 1, 2, 2, 2, 3, 4 is right. I mean, okay. I don't know about this one either, but yeah, okay. Let's try the worst case real quick. I don't think it should change anything, but also let's get rid of the debugging things, especially the low stuff. Times, well, how was it? 10. Huh? What am I doing wrong? Is that wrong? Too many. I don't know. Maybe today I just don't know how to program. But okay, that's, I mean, it's not fast, but it's fast enough maybe. I don't know if I could get that much faster. So let's YOLO go. No wrong answer yet. Maybe? Okay. Okay, well, jinx myself. Wait. Isn't that the input? Did I mess this up? Oh, I changed. What did I change? Because I had it was the right answer and then I changed something and now this gives me the wrong answer. Huh, that is funny. Because I checked it, but then after I ran the running speed test, then I guess the answer changed and then it's just wrong because I wouldn't have submitted, obviously. It's very sad actually. But okay. Am I still off by 1 here? Okay, you're trying to solve for 2. Okay, fine. Cost is 1. Is that true? Yes. Cost is 3. This one is not so true. Is it? One, 2. No, that's 1, 2. No, that's not 3. Why would it get 3? Why? That doesn't make sense, actually. How does that get 3? I mean, something here is wrong, I suppose. Okay. Maybe I just had 2 bad mistakes cancel each other out, I suppose. But that's still pretty bad. That I mean, what a waste of 5-minute wrong answer. Okay, I mean that's fine. Not great, but fine. Let's just do a print real quick. So this should be 4 returns 2, which is for this one, I think. But okay, something is weird. So this returns 3 because that's 1 element, right? Do I call that? Or bit mask? Why does it not? Okay, so it calls it for 4. Is that a 4? Yeah, that is a 4. Did I mess this up? Oh, I did. Okay. I actually forgot about I actually totally did forget about it. So we want to remove it. Otherwise, we still want to remove it. But the cost is plus. Yeah, okay. So this is the case. No, okay, so if it doesn't exist, then we want to add to it, which is different, I suppose. This is very awkward to write though. I mean, okay. The reason why I write it this way is so that, because I'm subject to change. But that didn't do it, huh? I mean, that's definitely maybe wrong. Bit mask 4. Why is 4 giving me a 3? No, 4 gives me a 2, right? I had this. Oh wait, no, is it a 2 or 3, Larry? One move gets rid of these 2, and then it's just 1, 2. So there is a 3. Wait, is it a 3? Am I thinking a bit dumbly? I mean, maybe. Okay, here. So you have a 1, 1, 2, right? So you have a. Why am I getting 3? Oh, okay. So you remove the pairs. That's 1. Oh, maybe this doesn't work then, huh? Because okay, yeah, okay. So this is wrong because I assume that you always want to pair up. Which is apparently not true. Yeah, that's not true, is it? Oh, but then you have those 2, and that is clearly suboptimal. Huh. Wow, I spent a long time to not. How much time do I have left? Oh, I guess this is not accurate. Is there anything that has tells me? Oh, 26 minutes. Huh, I may not get anything. For this one. How do we think it? I made a really wrong reduction, huh? Wasted a lot of time on that reduction. Okay, let me think. Is there a more dumb move? I mean, a lot of people solved this one, so I don't think it's supposed to be a hard one. Okay, that's a really bad reduction. How does? Okay, so it's this part. I feel like it's just a DP part, maybe. So this is definitely okay. Huh? I can't tell if this is just an edge case on this though, because for most numbers you want to pare them down. The reason why you never want to pare these down is well, you only have 3 of these, right? So maybe we can abuse that. I think it's still true. Well, no, it's the thing where you do, but a lot of them are paired up. So a lot of it is not that possible, but you do. Man, I'm thinking about this far more wrong with the dynamic programming, huh? Alright. Restarting during a problem is such one of the hardest things. So I have to maybe restart. I don't think it's just about doing that. Is it an algo? Is it greedy? Maybe it's just greedy. Maybe the DP is just silly. Basically, you want to. Okay, so the number of fixed moves are fixed. So you just want to try to avoid using zeros as much as possible, right? So it's like a maximum bipart, I think, except for it should be much more straightforward. And the reason why pairing doesn't work is because I force it, all the other numbers to the last number to do it. There should always only be one number where that is not true, so maybe we could brute force it. What is it? 100,000. So you wouldn't be at a thing, it's kind of slow though. And this has the same issue with this one. So the thing is that when you end up with one number, that's the problem. Because that number, okay, so you can't do it from the min up. I think that's the thing. And pairing only works on bigger numbers, so only have 15 moves. So that means that, what does that mean? We only have 15 moves. That means that your answer will always be at most 15 off. So we have to adjust for the pairing. That's not great. 19 minutes left. The DP is fine, but the setup to it is not actually. Every time you pair, I mean, I think as long as you pair a number with a bigger number is fine. Until all numbers are the same. That doesn't feel like an easy way to do it though. Especially 100,000 queries. Because even 100 is probably too slow. So there's something dumber than that. I mean, this is kind of nice, but it's just not right. We have to reduce it a little bit. How do I reduce it a little bit? Is it only wrong for? No, the cases definitely you can do on the boundary, like 14, 15, 16 or something. So then now you have 2, 1, and then now you move it in. So how do I fix that? So the one number state is the tricky part. Number left, because then you could borrow from the future. That's how do I do the borrow from the future? Huh. Okay, so the min number of, maybe I could think about it the other way. So min number of moves is just the sum of this matrix kind of thing, except for am I just overthinking this? Maybe. Let's see, right? So, okay. I mean, we're also getting up to running up low on time, so I guess we have to think about this. Okay, so here, added by a sub I times I, right? Because that's just the number of moves and the count. What does that look like? 6 and 8. Oh, I have to remember to divide it by 2. Is that enough? Yeah, that'd be funny if that's it. Actually. Alright, I mean, we don't have that much time. I'm 15 minutes. Maybe it's worth buying a wrong answer on here. So this does have one number left. So I think I just messed up here. Okay, let's YOLO try again. I should have known that one though. I don't know if this is right, but this one I should have known. Okay. Oh, it's each query. Okay. I mean, now I'm just like doing YOLO things. But I should have known this one too. Maybe that's why people got so fast. People are just not dumb like I am. Let's get rid of this real quick. I can't really prove this, but maybe I can. I don't know. Seems like it's still wrong. Yeah, this is off by a lot. Wow. How is that off by that much? Actually. That's actually... Okay. Then this is definitely not right then. I thought maybe we can work something out, but this is just off by a lot. So it's not a mod 1 situation. Why? Why not? How can it be off by that much? Because one number should be off by... I don't get it, actually. Let's see. What would be the difference here? Just for science. I mean, my numbers are very similar, so maybe I'm just thinking of... Am I just not understanding this problem correctly? It's possible. Is this right? I don't know. It's probably right, right? Well, this number having zeros is probably the reason why this is wrong. Why do I have to... Okay, maybe we could debug that. Am I just wrong on the... okay, it's a good thing we have. Does that fix it a little bit? Does it fix it to the right answer? It does. So I'm just dumb on the 17. Okay, that's fine. Is that the right answer actually? Okay. So I'm just dumb on that one. Okay. I mean, I guess I complicated this thing way more than I thought. Yeah, I mean, okay. It wasn't that bad. But all this DP for no reason. Alright, let's get rid of it. I was very wrong on this one. And honestly, the reason how I got this one is because it is a classic situation of, if this is not true, I don't know how to do it. Like it's a YOLO greedy-ish. It's not even greedy, but I think, I mean, I get. I feel like I have a proof on this one, but it's just like it's not a tight proof. I like, there is some like proof around like it being contiguous, which is why this works, because there's no jumping, but it's such a hard thing to prove. Though I did do math. Why is it? Oh no, why is 15 not? Oh wait, no. Why is 2 to the 15 not enough? Huh? Why did I have to? I mean, that was a silly one wrong answer. Oh, let me also take a screenshot. 905. Wow, people did really well with this contest. Jeebus. I mean, I wasn't fast, but I don't think I was this slow. What was Q3 again? I don't even remember the problem anymore. And apparently, Leetcode neither. It's taking so long to load. Oh, this one. People really fast on that one, huh? I mean, that one I'm not. Well, I mean, maybe not this fast, but I'm not super surprised that people are fast. Just because I don't know, I'm really bad at math, so like that one I'm not super shocked about. But this one I'm a little bit sad that it took me so long, but maybe not. I mean, I didn't really take that long once I realized it's not DP. I really thought it was DP. I just kind of missed the one case, the one really important case, and then I got. How did I get 4 wrong answers? Oh. One of them was because I did DP. This was one of them, but I did it on only. Yeah, it should have been per query. And I don't know how this. Still don't know. Why is the? Why am I? Is it just 16? What? Huh. 4 to the 15 is 10. Am I doing? Oh. But this has to go further because of the thing to get the max, to capture the max over. No, okay, maybe I'm just dumb, but okay, well, yeah, I mean, that's all I have with this one. I don't know, I guess people are really smart. Maybe I'll see if I can learn something. People did Q2 pretty well. I actually honestly don't remember any of the problems other than Q4, so let's do a quick mini review. Okay, Q1 is fine. It is. Oh, Q2, yeah. Also silly. Q3, I think the hardest part is 5,000 thing. I guess they do it so that you don't do n. Like, so that you get rid of the log n factor, but that's still really crappy, right? Like, how is anyone supposed to know that it's okay to for a problem to run 14 seconds? It is just ridiculous, Leetcode. But okay, and Q4 is just this one, which I took a long time on. Let's see if I can learn anything by clicking on some solutions. What did people do to Q3? I guess people just did math on Q3, which wouldn't surprise me, especially when math has this fun ChatGPT thing. Yeah, I mean, I want to do something like this. Like, I'm not surprised that people could get in 10 minutes, honestly. I had a typo also that took me a long time to fix. And then I was just doing silly things. I had 2 typos, I guess. So I didn't get any wrong answers, but it wasn't like a good answer. I guess I'll look at it because I expect. I mean, yeah. This was the idea that I was trying to think, but but that way, oh. Huh. Yeah, I mean, maybe I don't know. The way my reasoning, maybe it's just not as clean as Ui's. I mean, obviously not. They were 5 minutes. Oh yeah, no, I mean, I can see how they get in 5 minutes. Honestly, this is a way. Like, I mean, if you're good at math, I feel like that one maybe is intuitive. I think that for me the hardest part is just about the proof. I guess a lot of people just got it from that because it's not really. Like, you may not be able to prove it, but people just YOLO, and maybe that YOLO is good enough. And also maybe a lot of people cheated. Let's take a look at some random dudes. I mean, okay, maybe just a lot of people cheated as well, but I don't know. Yeah, I don't know. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.